Hello Minecrafters and welcome back to another Redstone video. This is episode 7 of Learning Redstone Computer with Minecraft, and in today's episode, as you can hear, my audio is not horrible anymore, at least I hope. But yeah, I have changed my microphone a little bit so it sounds significantly better than all my previous video, and I hope that this audio quality will stay the same throughout this video. Anyways, in today's episode, we were gonna basically implement for loop and conditions to our program so we can make our computer Turing complete. So just sit back, relax, and let's jump right into today's episode. The very first thing that you need to do before we continue our episode is watch MapAtWing's video. Right, you need to actually watch that video first, then come back to this video, because I will not gonna go in depth into all of the definitions and explanation stuff. I'm only here to show you how to actually build it in Minecraft. Okay, so if you haven't watched it, go and do it. I will gonna wait. Okay, done. Great. Let's go to our spreadsheet. Okay, so here is my spreadsheet that I have created, because as you can see, we have a lot of operation over here, and well, we need to actually note them out so we don't forget. So basically, this spreadsheet is very similar to MapAtWing spreadsheet. I just make it my own so I can understand, but I have written it in a way so that maybe you can also understand. Also, I write this thing wrong, so let me fix that real quickly. There we go. Anyways, here we have our instruction, and the instruction structure is a 16-bit binary string. We have already known this, and we have divided the instruction into two parts. The first part is the operation code, and it is a 4-bit binary string going from 0 all the way up to 15, and the operands, which are the other 12 bits in the instruction bits, and we have divided stuff like this over here. Then we have this, and I will gonna get to this later, but if you have watched MapAtWing's video, you probably know what this is. Then minoic, is that how you spell that? I don't know, but basically how you were gonna write this in the assembly program, and the description. Now here is the different part. I have written this to be as clearly as possible. So the objective of today's episode will be implementing these 3 new operations, because so far in our computer we have these operations. So the last episode we implemented the halt operation and the LDI, or the load immediate operation. Today we are gonna add these 3, and first is this one. This one is add immediate. It is the same as this one, but if you read the description, you will see that we are gonna add the input data to register A. So instead of load immediate, load the input data to A, we can add this input data right here into A. Next is jump. Now jump is basically a way for us to go into different parts of our program. Again, watch MapAtWing's video to actually understand this, but with this operations, we can basically jump around in our program, hence the name. And with this operation, we can basically create a loop. Now for conditions, we have this operation, and this is branch, and it acts similar to jump. As you can see from the description, it also loads a 10-bit binary address into our program counter, because our program counter is going to control the instruction going into our LRU and our register. However, what's different between branch and jump is branch has some conditions. So it has 2 bits conditions and then 10 bits binary address. And we are gonna implement two flags. Again, watch my Wings video to understand this. But we have a zero flag, and this zero flag will appear when LRU output is 0, and a carry flag when the LRU carry out bit is 1. Also for the branch condition, which is the 2 bits condition here, if it is 0 0, the 0 flag is true, 0 1, the 0 flag is false, 1 0, the carry flag is true, and the 1 1, the carry flag will be false. So yeah, in today's episode we will implement these 3 operation and this like branch thingy, and yeah, that's basically it. Today's episode will be a bit complicated in terms of explanations, but for redstone wise it's actually not that hard. So let me show you how to do this in Minecraft. Okay, so in order to add the add immediate operation into our control ROM, first you need to make a new like slice over here for the add immediate. Then of course you need to reprogram this part right here of the encoder, because the add immediate in our spreadsheet or our operations is 9, so the operation code is 9. We have to input 9 here, which is 1 0 0 1, just like that. Then we need to encode the functions of the add immediate. So we need to actually tell the add immediate what to do. The first thing it needs to do is activates the register, so this is the enable line, and then we have to add a new line which we're gonna go to this mux right here. So this is a mux, and I have showed you how to build this already in the last episode. It is the same thing as this mux right here. So we have a mux over here, and we have that line, like this line of the add immediate over there, and with spaghetti wiring to here to basically cancel the input lines of this side of the LRU, and then we input our data bits into the LRU. So yeah, that's basically how it works. Now I'm gonna show you a program that I have written. So over here I have loaded in a program which has the add immediate operation. So the first line over here will basically do the load immediate. So it will gonna load immediate to register number 1, a number 1, and as you can see on the output, we can see that opcode is 1, which is load immediate, then register number 1, and then the data bit is 1. Then for the second line of our program, we have the add immediate here. As you can see, we have 1 0 0 1, and then at register number 1, and we want to load in number 2. And what this will do is it will gonna add 2 with 1 over here at register number 1. So in theory we should be able to see number 3 at register number 1. So yeah, let's run our program. Let me go over here, press the clock signal, and now we are gonna go here. Oh, I forgot to reset, but basically as you can see we have a 1, and then we should see a 3 because 1 plus 2 equals 3, just like that. And yeah, we have successfully execute the add immediate. Of course I have added the like the halt signal over here as well, so the halt operation. So now the program has reset and our program is finished. So add immediate is functional. Now the next thing we need to add is the jump operation. So yeah, let's do that next. Now in order to add the jump operation is very easy. Basically you need to grab the bottom 10 bits of the instruction, like binary string here, and then you need to wire those 10 bits into the program counter. So you're basically gonna overwrite the program counter with the new address. So yeah, let me do that really quickly, and I will gonna show you how I did it in redstone in more details. Alright, so for jump first, I basically combine the bottom 10 bits from the instructions, and I basically redirect those 10 bits down to here, and here I have a mux which allows me to select either the normal default program counter, so the current address over here, or if I want to overwrite with a new address over here, and this address we can assign in our program. I also add a new slice to our control ROM, and I forgot to write, so this slice right here we're gonna be jump, or like this. So this is our jump operation, and the way we encode it is we have a new line over here, and this line we're gonna spaghetti wire all the way down here to activate this mux, which allows me to either select the output from the program counter, like the default output, or the overwrite output, which are these gray lines over here. Now in the program instruction memory here, I have written a new program. So the first instruction is LDIR11, so we load number 1 into register number 1, and then the second instruction is ADI-R11, so I basically just add 1 to the register 1, and the third instruction here is the jump. As you can see, it is the jump operation 1010 or 10, and the address that I will gonna jump to is address 1, and address 1 stores this instruction right here. So basically this jump, we're gonna jump back to like this instruction. So this jump instruction, we're gonna tell the program counter to jump back to this instruction and execute this, and this loop we're gonna continue basically forever, and we will never gonna reach the halt instruction over here. So yeah, let's try that. I have a clock, it's over here, so let's press it, go to over here, and let's see. So it's 1, 2, and I'm setting the tick rate to be rather high. Now it's 3, and then should be 4, yep, and then 5, yep. And if I just go to the program counter, you can see that the program counter alternates between 1 and 2 because this is an infinite loop and it kind of skips, and this line will activate to switch the outputs here. So either we accept the output from the program counter or the output that we overwrite in the that we store in the instruction memory. So yeah, we have our jump function or operation. The final operation that we need to add in today's episode will gonna be the like the branch operation. This operation is a bit harder to implement. It's not too difficult, but with the current limitation in space with our LLU, it's kind of hard for me at least. I will try to make it as compact as possible, and yeah, let's see how this turns out. First are the flags. How can we achieve and like make those flags? Well, we have two flags, the carryout flag and the zero flag. Now if you want to fully understand what those flags are, again watch my Batwings video, it's very important. Anyways, in order to actually get those two flags in our computer, is very simple. For the carry out flag, here it is. It's basically the carry out of our adder, the white circuit port. As for the zero, it's basically these zeros right here. So these bits right here, we basically have to OR all of these outputs together to get the zero flag. So yeah, let me do that really quickly. Okay, so I have the carry out flag over here and the zero flag over here. Now I have done something a little bit cursed when it comes to computational redstone, that is using pistons and also using some wireless redstone. So I don't know if you accept this, but hey, this is my computer. I can do whatever the hell I want. Okay, so yeah, basically I use some wireless redstone over here to detect the output of the LRU, since as you can see I have no space and I'm too lazy to move things around. So I think this is good enough, I guess. And then I just spaghetti wiring the like the zero flag to the top, and now we have both the carryout flag and the zero flag. Okay, you can judge all you want about the redstone. It is my computer. I can do whatever the hell I want. Okay, so yeah, to all of the haters, keep complaining. Anyways, the next thing that we need to do is to actually add the all of the condition thingy in, and it's actually really simple. Step one is to split the flags into our 4 conditions. So condition 1 is 0 flag true, second condition is 0 flag false, then carry flag true, and then carry flag false. After that, we are gonna add this decoder right here, which allows us to enter the conditions, and then we have a bunch of AND gates here to check whether the condition and the flags here are matching. So for example, condition 0, meaning the flag needs to be 0 flag true. So if this line is on, that means we can select this flag right here, and that will allow us to get an output over here. What we have to do now is to wire this output with this line right here, which we're gonna go to the mux that we have in there. So yeah, let's do that, and in theory we should have branch completed as well. So I have done just that. As you can see, we have another wireless redstone here to go all the way down there, and this part will connect to this line, which will go to the mux that we have over there. And also I have encoded the branch here so that it will gonna activate, basically allow the flag encode here to go into the decoder, and also allow this part to activate using this line, and there's a repeater there, as you can see. And now we should try and run this program to see if our branch operation actually works. So I have prepared a program here. So this program, first we're gonna load in a number 1. Oh wait, not number 1, but load number 3, as you can see, into R1, and then it will gonna do add immediate 1001, and we were gonna add immediate to R1 255, and this is basically a way for us to do decrement. Again, if you don't know why it works, watch my Batwings video about this. Again, everything is my Batwings related. Okay, so if you don't watch my Batwings video, my videos won't really help much. Anyways, we have add 255 here. For our next address, we have the branch operation check, so it's 1011 or 11, and we use 11 for our branch operation. So opcode 11 is for branch operation, and we are gonna see if we are gonna get this condition, and if the branch is activated, we were gonna go to this address right here, which is address 4, and the code that we are gonna check is the 0 code true, or the 0 flag true, which is 00. So if we enter 00 to the decoder and the LRU has the correct flag, basically 0 flag true, like that, we are gonna get an output here, and this output we're gonna go to the mux that we have over there. Finally, we have the jump operation 1010, and we will just gonna jump back to register number 1. Oh, not register number 1, but address 1, which is this address right here. And we also have a halt signal over here, so we can end the program. So yeah, let's just run the program. Let's go down here and press this button. And if I remember correctly, I have changed the tick rate a little bit, but yeah, let's change it to 500 so we can see the effect much faster. So I click tick rate to 500, and then I think I will gonna tick freeze, so we have time to move to our register file. Again, I have pressed the button. So now if we go to our register file and go to R1, which is these two registers over here, we should see that first we will get a 3, and then a 2, and then a 1, and then 0, and then the program will gonna stop. So yeah, let's try that. If I tick unfreeze, we should see a 3, and then after a while we should see a 2, and then a 1, and then 0, and then the program should stop. Okay, now we have a 2, 1, 0, and then we should get a 0, 1. Let's see if we will be able to get that. And there we go, we have 0, 1, and now we have to wait a little bit more to get 0, 0. And when it is 0, 0, the branch operation should activate, and we should jump to the halt signal. And now if I go back to here, we should see that, yep, the latch has reset. And if we look at the program counter, we can see that we are back to address 0, which has this instruction over here. So yeah, our branch operation has fully worked. We have successfully implemented the branch operation. And that will be it for today's episode. Again, I really encourage you to do this by yourself. Okay, that's the purpose of this series, because well, if you just download this world, it wouldn't be that much of an education journey for you, right? So yeah, you should try to connect it. Again, if you have any problems, you can go to MapAdWiz Discord server and ask questions there. I am very active over there, and if I see your post, I will make sure to answer it. Okay, so yeah, that's the end of today's episode. Thank you very much for watching, and I will see you all in the next episode of Learning Raster Computer with Vadcraft, or a different video. I do have a really cool future video for all of you to enjoy. So yeah, let's see if I can finish that. Okay, bye bye, see you all later. Have a nice day, everyone.